Algebra 2, lesson 3.2, complex numbers. So all the numbers that we've encountered prior to this lesson were considered real numbers, right? So we could have decimals, negatives, positives, square roots, fractions. These are all just considered real numbers. Now, anytime a number has the letter I in it, it is considered a complex number, okay? Because the letter I is considered the imaginary number, okay? So today you guys are going to learn about the letter I, right? Which is considered the imaginary number, okay? So anytime you see a value, right, that has the letter I, right? For example, it could be like 3i, or you could have even a binomial like 4 minus 2i. If you see anything like this, this is considered what we call a complex number, okay? It's considered complex because 4 is a real number, and the part with the I is considered imaginary. So you've got a real part and an imaginary part, so that's what makes it complex, okay? So just remember that anytime you see some sort of value with an I in it, that means that that is a complex number, okay? So why do we exactly need this imaginary number, okay? So before, when you had something like square root -4, your teacher probably told you that the answer was no solution, or you cannot simplify that, right? So today, right, using the imaginary number, what it does is it allows us to simplify square roots or any even index radical, right, with a negative inside, okay? So that's basically the purpose, or what the imaginary number allows us to do. So the imaginary number I is defined as the square root of -1. Okay, so it's very important that you remember that. So anytime you have a negative inside a square root, you know that you're going to have to use, all right, the imaginary number I. Okay. Now another one that you need to remember, all right, is that I squared is equal to -1. Okay. Your answers can have an I in it, but it should not have I squared. If your answer has I squared in it, you need to substitute -1 for the I squared. Okay, so just remember that any final answer you have when you're working these problems out, it's okay to have I, but you cannot have I squared or something higher, I to the third or I to the fourth or anything like that. Okay, it's okay to have I. Alright, so let me show you how to simplify these radicals, right, using the imaginary number. And it's actually really simple, right? So it's like one extra step. So before, when you had a square root and you have a negative on the inside, right, you just left it like that and you would say there's no solution. Well, now all you're going to do is, when you recognize that, oh, the square root has a negative on the inside, you're going to put the letter I on the outside and it makes the number on the inside positive. Okay, the reason why that happens is the definition I is equal to square root -1. So when we put the I on the outside, the number on the inside, right, becomes positive because of this definition here. Okay, because -4 here is the same thing as -1 times +4, right? So when you put the I on the outside, you've done this already, so you got rid of that -1 on the inside, so that's why the 4 becomes positive. Okay, now what's the square root of 4? It's 2. So your answer to this would just be 2i. Okay? Same thing with the 50 here. I see the negative inside the square root. I put the I on the outside. Then the 50 becomes positive. And then I just simplify this like I normally would, right? This is 25 times 2. The square root of 25 is 5. So I have 5i on the outside, and the 2 stays inside the radical. Okay? So all the simplifying, all right, you should already know how to do. So the only thing really new is you just have to remember, whenever you have a negative inside a square root, right, put the I on the outside and it makes the number inside the radical positive. Okay, so that's really all it is. So example 1 here, so let's simplify these. So first, I'm going to put the I on the outside. The 25 becomes positive. What's the square root of 25? It's 5. So my answer is going to be 5i. Okay. Same thing here. I put the I on the outside. The 72 becomes positive. Alright, 72, that's 36 times 2. What's the square root of 36? that's 6, so we have 6i on the outside, and square root 2, right? Over here, we have the negative 5, right? So I'm going to put the I on the outside, and that square root, right? Square root negative 9 becomes positive 9 on the inside. What's the square root of 9? That's 3. So 3 times the negative 5i. Right? So remember, we're multiplying these values. That gives us negative 15i. Okay. Now adding and subtracting, right? So when we're adding and subtracting, it's just like if this was, instead of I here, if it was just x, you would just combine the like terms, right? So it's the same thing, just combine the like terms. So which ones are like terms? So the 8 and the 5, they're normal numbers. That gives me 13. The negative I and the positive 4i gives me positive 3i, and that would be my answer. These two are not like terms because the 13 doesn't have an I, so I cannot simplify them. Okay. Whenever you're subtracting, right, you have to be careful. So whenever you're subtracting, right, you want to distribute this negative. Think of this as like a negative 1. So you have to multiply it here and here. So basically we're going to end up with 7 minus 6i. So this part stays the same. And then when you distribute the negative 1, that becomes negative 3 and then a positive 6i. And then we combine like terms. So the like terms, 7 and negative 3, that's going to give me 4. And then negative 6i and positive 6i, they cancel. So that's all I'm left with right there. Okay. Over here, anytime you have a negative in front of a parentheses, you have to remember to distribute the negative to everything inside the parentheses. Okay. So we have this 13 here. I have to think of this as a negative 1, right? So distribute the negative inside the parentheses. That makes that a negative 2 and the negative 7i. And then we have the positive 5i on the outside. Now we combine like terms. So 13 and negative 2, that's 11. Negative 7i and positive 5i, that's negative 2i. Okay. Multiplying complex numbers. So when we're multiplying, all we do is we just distribute here, right? We're going to distribute this here and here. So we'll get negative 24i, and then we'll get plus 4i squared, right? Because I times I gives you I squared. Now remember, I told you before, your final answer cannot have I squared in it, okay? You can have an I, but not I squared. So remember earlier we said that I squared is equal to negative 1. So if I squared here is negative 1, right? So we have negative 24i, and then we have this positive 4 times negative 1. That'll make that negative 4. And then this will be your final answer. Okay? So it's okay to have I in your final answer, but you cannot leave it with an I squared. Okay? Over here, we're going to FOIL, right? So we multiply. That's negative 36. Multiply here. That's positive 63i. Multiply here. That'll give you a positive 8i. And multiply here. Looks like that's going to give you a negative 14i squared. And we know I squared is negative 1. So negative 14 times negative 1 makes it a positive 14, right? So now let's combine like terms. So negative 36 and positive 14, that's going to give us negative 22. And then these are like terms right here with the i's. That would be plus 71i. Okay. All right, let's take a look at how to solve quadratics, all right, involving I. So let's take a look at example A here. So if you recall from our earlier lessons, this is an AC problem, right? We only have A and C in this problem. When you only have A and C in the problem, remember we want to get the x squared by itself. So I'll minus 4 to both sides. That'll give me x squared equals negative 4. Once the x squared is by itself, now I square root, right? So the square root cancels with the exponent. So I get x equals. Now don't forget the plus minus because we square rooted both sides of the equal sign. Now there's a negative inside the radical, so we're going to put the I on the outside. The 4 becomes positive, and what's the square root of 4? It's 2. So our final answer will be plus or minus 2i. Okay? So that's all that is. Same thing with example B here. So first you have to recognize that, oh, I'm solving a quadratic and it only has A and C. So I want to get the x squared by itself. So I'm going to add 11 to both sides. So 2x squared is going to equal, if I add 11 to both sides, I'm going to get negative 36. Right? Divide by 2. X squared is going to equal, I get negative 18. Now that the x squared is by itself, I square root both sides. So x is going to equal, put the plus minus. So first I'll put the I on the outside. The 18 becomes positive. I need to simplify the square root 18. So 18, that's 9 times 2. What's the square root of 9? That's 3. So I'm going to get x equals plus or minus 3i, and then we still have the 2 inside the radical. Okay? And then last example, so we need to find the zeros of the quadratic function. Okay? Now you have to remember that whenever they ask you to find the zeros, that's the same thing as solving, right? It's the same as solving. It's just another way to say solve the quadratic. Okay? So to find the zeros of this, first we're going to make f of x, right, 0. Okay? F of x is the same thing as y. If there was a y there, you would make y 0. Okay? And then we have 4x squared plus 20. So I notice, hey, this problem, right, only has a and c. So I need to get the x squared by itself. So I minus 20 on both sides. 4x squared is equal to negative 20. Divide by 4 on both sides. So I'm going to end up with negative 5 is equal to x squared. Square root both sides. So I'm going to get a plus minus. Put the I on the outside. Square root 5 is equal to x. And then I can't simplify square root 5, so I'll be done. Okay? And that's all that is right there.